Okay, that's why we call the private variables inside the class instance variables. Why do we call them instance variables? Because they belong to each instance, to each object. Just like I'm looking at you right now, Jawan, right? So for this instance, the name, for every student, you have a name, you have an age, you have an ID, etc. So for Jawan, this instance, the name is Jawan. For the one on my right, that's Daniel. So both of them have the name attribute, that's from the model, from the class, but their values are different. That's why we call them instance variables, because that variable belongs to instance. That's what that is. Okay, so today we will discuss chapter 7. Let me let me share this. Who just came in, Isaac? Or I think it was Isaac, right? Okay, so let's start this. Okay. Okay, chapter 7. Chapter 7 is object-oriented design. You know, when you work through a project, you need to design it first. For us, the project is very simple. But if you work on a system, you want to solve a real big problem, you need to understand the problem and design first. So this is the object-oriented design. Okay, let me get this. Okay, so these are the things we are going to concentrate on. And software development activities, we briefly discussed this in class 1. So how do you develop a program? These are the 4 things you must know. You must do. Establish the requirements. You remember when I give you a project, I have the description of the project, right? That is the requirements. Okay, in mine, it's mainly telling you what you have to do. But if a customer gives you a project, it's mainly telling you what they want, right? So you need to analyze that and understand what they want. And then you will design, how do I solve this problem? You will create the design. That's where you really draw the UML diagram. If you remember last class, we discussed the UML diagram. That's where you draw that diagram, establish, find the classes and establish the relationships. Okay, and then you begin to write the code that's implementing the design. You write the code, that's the coding part. And a lot of times students feel that coding is the most important thing or the most difficult thing. Actually, once you understand the requirements and you have a design, it's very easy to code. Okay, the next one is testing the implementation. You need to test it again and again using different scenarios to make sure your code works correctly and it's bulletproof. You can never be bulletproof. Let's be clear about that. But you try to be as perfect as you can with the code. But as I said, you can never be bulletproof. Think about Windows, Mac, all those operating systems. They keep updating, right? They release patches. Why? Because it's not perfect. So you have to keep updating it. Okay, that's the testing implementation. You need to test it again and again, and even release it and let the user test it, right? And after that test, you release the full version, but then users are still testing it. So testing is a never-ending process, really. So that's why when I grade your project, I tell you that test thoroughly. That means you need to think of all the scenarios. For example, if you have an if-else statement, you know, if that's the main purpose of your project, you need to make sure you test all the scenarios, right? If you have 4 scenarios in the if-else statement, you need to test all those scenarios. If you have a while loop, and your condition is less than 0, you need to test the situation where the number is greater than 0. and less than 0 and equal to 0. This is called thorough testing. Okay. Requirements. So you can read this. This is really not difficult to understand, but you need to know it. You do have a question on the quiz or the test. I forgot, but it has something to do with this part. Okay. So requirements is the customer's requirements. It tells you what to do. That means what I want as a customer, right? So you need to, my internet connection is not stable. You need to understand what the customer wants. Okay, sometimes it's very clear in the requirements, but sometimes you need to discuss it with the customer and go back and forth until you completely understand it. The next one, so that's the what part. Design is how. So now you understand what the customer wants. How do you design this? How do you solve this problem? That is the how. That's really the design here. Okay. And I will let you read this because if I do it, I'm just reading it. There is not much implementation. I already explained it. Implementation is the coding part. And the testing, we discussed that. So those are the 4 parts of software development activities. Understand the customer's requirements, analyze it, and then create your design, your solution, and then implement, translate it basically into code, whether it's in Java or C++ or Python or Visual Basic or whatever language you are translating it into. That's the implementation. So the design really is not so much related to the implementation. But of course, you want to think about the language you are going to implement it, because some languages are not object-oriented. So if you have an object-oriented design, then with C, you cannot implement it because C is not object-oriented, right? So there is some relationship, but in nowadays, it's not as important because most of the time people use object-oriented language. Okay, now let's go to identifying classes and objects. So when you talk about, I'm silencing my phone, okay. When you talk about object-oriented design, how do you solve a problem? How do you make the design? It's really the activity of identifying classes and objects and then establish the relationship among them. That's what your design is. And of course, you will have the sequencing, right? Which class is used first, you know, sequencing diagram. That's more of the flow chart. But in OO, we don't call it flow chart. We call it sequencing activity diagram. However, okay, but here, let's come back. I'm going too far. So creating the design is really identifying the classes and objects and establish their relationships. Okay, so how do you identify the classes? The classes may be part of a class library like string, random, you know, they are part of a class library. You do not need to write it. You do not need to design it. You just need to use it, right? So, or it's a class that you have written before and you can take it and reuse it. And that's the key for OO. When I say OO, everybody, it's object-oriented programming design, OO. DOOC, that's object-oriented design and object-oriented coding. Okay, so OOD. So you can take a class you have written before and use it. And that's actually what OOD does. It saves time because you have already written it. It's an object, so you can take it and use it versus in non-object-oriented programming languages, everything is from top to bottom. Okay, you cannot take this piece, and you can, but you have to copy and paste it, right? You have to implement it integrate it into your code. It's very much more difficult. and not clean cut. Versus in OOD and OOC, you really, OOP, not OOC, I'm sorry, OOP, object-oriented programming. Okay, in OOP, you take the object and you can plug it in. It's plug and play. Okay, so you can use a previously written object and use it. One way to identify potential classes, okay, is to read the requirements and identify it. And objects are generally nouns, okay? And the services that the object provides are generally verbs. And services basically are the methods for the class, right, in the class. So nouns are most likely objects, and services, verbs are the methods. So, however, not all nouns are objects. Okay, some nouns may be simply attributes of other objects. So here is what I'm written here. I have written here just a rule to help you understand. An object is something that is impossible to represent with a single primitive data type, or an often used class type such as string. It has to be broken into smaller pieces. So if it is an object, you cannot represent it with an int or a double or a float or a char or a string. Okay, it's too complex. You have to break it into pieces of information. For example, okay, here is an example. Price of a book. Think about price of book. How do you represent it in programming? What data type would you use, right? You will use an int or a double, and that's it. That's enough. There is nothing else you need for this noun. But for book, okay, it's overloaded, really. It's loaded with pieces of information. It cannot be represented by a single primitive data type. For example, can you say, okay, I can use a double to represent a book? You cannot. Why? Because a book has an author, right? It has a publisher, year published, price, ISBN, etc., a lot of things, title, number of pages, all those attributes are composed, a book is composed of all those attributes. So a book is a complex thing. It's an object. It has many attributes. You cannot represent it with a single primitive data types like these. Therefore, a book is an object. You cannot use a single data type to represent it. You have to create an object. Does that make sense, everybody?
Yes.
Yes, okay. Okay, so now let's look at another example. Okay, letter grade. Think about letter grade. You can simply, a letter grade is simply A or B or C. That's it, right? There is no other information that needs to be represented. So a letter grade can be represented with a char, data type char, and that's it. But if you think about a test, okay, a test, it's very complex. Why? Because a test has the subject matter, what it is based on. It has the number of questions, total points, the type of questions. No, type of questions belongs to question. Okay. So for test, you cannot use a string to represent it. You cannot use a double. You cannot use an int, etc. So it must be an object. Okay, another example. I'm giving you many examples so that you understand the difference between an attribute and an object, and also when do you need to make it into an object, right? Okay, salary, you can represent it with a double or int. Employee, however, on the other hand, it cannot, because an employee is a complex object, because it has to have a name, social security number, salary, classification, job title, age, etc., all those things. an employee is composed of all those attributes. So salary is simply part of an employee. Okay, therefore, employee is an object. It does not exist in the Java library. And what do you need to do? You need to write it. Like in chapter 4, we learned how to write a class, right? So now for employee, if you need it in your project, you need to write it. Okay. So now given that, let's look at this partial requirements document. Okay. So if you read this, the user must be allowed to specify each product by its primary characteristics, including its name and product number. If the barcode does not match the product, then an error should be generated to the message window and entered into the error log. The summary report of all transactions must be structured. Okay, so of course, not all nouns will correspond to a class. We already discussed that, right? If you look at this, letter grade is a noun, but it should not be a class because it's an attribute of something else. Salary is a noun, but it's not a class because it's an attribute of someone else, something else, right? So that's what this means. Okay, I will let you tell me what should be a class. Let me ask you. Think about user. Should user be a class?
Yes, user should be a class because there's different users that have like different levels of like access.
Okay.
The user has like a username.
Okay, a user has to have a username. Yes, and the access rights, right? This type of user can access this or that or that. Yes, a user must have a username, a password, for example, a real name associated, an email associated with the user, and what else? A level of access, right? Yes, so you cannot just use a string to represent the user. Okay, so that's a noun. We decide that should be a class. Okay, what about product?
Also a class.
Also a class. Daniel, explain that.
Well, product's going to have a product number, a barcode,
Okay.
various other things to its name. It's
yes.
not just one thing.
Yes, yes, exactly. A product, it's not just one thing. It's just, oh, a product name, that's it. No, a product has barcode, product number, name, and price, and all those things, right? Years it is created, etc. So it has many different attributes. So a product must be an object. What about characteristics? Is this a class, this one?
Characteristics.
Part of. Good.
I didn't hear you though just now. Brian and Jesus, I didn't hear you. Say it again.
Yeah, Brian can answer it. It's fine.
I was going to ask it, wouldn't it be part of product? Because it's the characteristics of it.
Okay, is it part of products? So are you saying it's an attribute of product?
Yes.
Yes, okay. Is it an attribute of product, everybody?
Yeah, I agree with Brian.
Okay, you agree. Well, here it's okay, think about it. Name, what is name? What about name? Let me ask you this question. What about name? Is it a class?
Yeah, name is also an attribute of product.
It's an attribute of product. What about product number? Is it a class?
Attribute.
Should product number be a class?
No, it should be part of the product.
It should be part of the product. What about barcode?
That should be part of product as well.
Part of the product. Okay, think about it. Can you represent name with a single data type? Danny? Can you,
I would say yes.
you would
This
say
one-
yes, give me the data type. What should
A
we do?
string.
A
You could
string,
use,
yes,
you use string.
it's not a data type, it's a class, but we are using it almost like a data type, right? Because it's used so often, but it's a class. But what about product number? Can you represent it with a single data type?
You can
Is
do
it a-
int or double.
Yes, okay, product number, an int or double. Mostly we would say int or long, or you can represent it with a string of digits also, right? So it's what you think is it a single piece of information, or is it composed of multiple pieces? And product number is a single piece of information, a string with digits, or long, maybe because product number is longer, maybe, or alphanumerical characters. So barcode, what about barcode?
It would be an attribute, right?
Okay, Danny, it's an attribute. Yes, so these three are all attributes of product. They are not classes, right? So characteristics, this is really an umbrella term for these three, right? And others. So characteristics is not a class, it's not an attribute, it's a term describing those attributes. So this is really nothing. We don't use it at all. It's just, it's a general term to reference all these attributes, right? So this is nothing. Okay, a product. Error, what about error?
Be a class.
It's a class, why?
Because there's like multiple errors with different names and reasons.
Okay, multiple errors and different names of errors and different reasons behind the error. Yeah, an error is, you cannot represent an error with a single data type, not an int, not an int, not even you say this is error 4404 or 404. What does that mean? Behind that 404, you have the reason, right? And you also have the solution, you have the cause. So error is not a single data type thing. It has to be a class. So for an error, you have the name, maybe, you have the error code, you have the solution, and you have the reasoning. And you may also have something like when it occurred, on what machine it occurred, you know, all those things. So that's a class. Okay, what about message window? This is a class. A window is so complicated. It's a class, right? It's in Java, you have window, which is a GUI component. Okay, error log. What about error log?
Yeah, that's a class as well.
Why?
Because kind of like the last thing you said about error, you have to log it to the time, the person that produced the error. Yeah, just like details about the error that can't just be represented by a single.
Yes, exactly. It's a log, right? So you have many different errors, and you have when it was generated, on which machine it was generated, etc. So error log, definitely class. Summary report. What about summary report? I need to ask you. If you don't answer, I need to look at all of you. Joanne, what about a summary report? Is it a class, or is it is it a class summary report? Joanne, I cannot hear you.
I'm here. I'm still thinking.
Okay, so generally, classes that represent objects should be given names that are singular nouns. So this is just a convention, and it's a good convention. A class usually use singular nouns. You don't use plural forms, okay? So coin student message instead of coins students message. That's the class name, remember. And notice that for each class, the writing form is you capitalize each word of the each initial letter of the word. Okay. A class represents the concept because it's just one concept, the concept of one such object. So what do I mean? A class represents the concept of one such object. I don't remember what I meant here, so let me take that out.
Are you trying to say that like because the name is a singular noun, like yeah, like for example, student, that the class is supposed to be like the realization of just one student, not all students? Like that's why you name it the singular?
Yeah, maybe. I think so. But for me to read it right now, it feels, I feel confused. I don't know about you. I think sometimes when you write something, you're so clear-minded at that time, but afterwards you read it, what did I mean, right? So yeah, I think that's what I meant, but I don't think this is a good statement. It's not very clear. I don't like it. I will change it. Okay. But you understand, Jesus, you explained very well. Okay, we are free to instantiate as many objects of each class as needed. Okay, you understand that already. What time is it? Identifying classes, I need to put this down. Identifying classes and objects, and we already discussed that. Sometimes it is challenging to decide whether something should be represented as a class. And for example, should an employee's address be represented as a set of instance variables of employee or as an address object? So this is a very good question. You think about it, an address, is it a single data type? Can you represent an address with a single data type?
No.
No, because we have it here, right? Because an address has street number, street, city, state, etc. Can you represent all these with a single data type? Yes. Can you just say address is a string and we just list all of them out? But then it will be very difficult to differentiate between the different categories of this address, right? So we want to make address into a class because we can separate them. And then we can change one piece of information at a time. So we break it into different pieces of information. Strings, we still break it into multiple pieces of information. This way, it's much easier to manage. So the question here is, should we put all these pieces of information into employee, or should we simply extract them and put them into another class named address? What do you think? Which one is easier?
I'd say put it under employee.
You say put it under employee.
Well, actually, no, man. I changed. I'd say address actually.
Yes. You want to extract them and put them and design create a class named address and put them there. What's the benefit of that, Aaron? Why do you think that's?
It's not just stuck to like employee. You can implement it to like different things separately.
Yes, exactly. Then you don't have to just you can use it in multiple objects. You can use it in what? Student. You can use it in CEOs. You can use it in anyone, right? Faculty, employee, staff member, student, anything. Who needs an address, you can use that class. So if you put all these, okay, everybody, if you put all these into the employee class, then when you write the student class, what do you have to do?
Make the same address all over again.
You have to do the same, exactly. You have to put all these information into the student class. And when you write the professor class, you have to put all of them into the professor class. You see, you're repeating what you are doing, right? Multiple times, which is a waste of time. Versus you simply make one class named address and put all this information into that one class. And then when you write an employee class, use address. When you write a student class, use the address class. So that way you are reusing that same class. And that's the benefit of object-oriented programming. That means you can reuse the classes. Okay. So now let's look at this. Part of identifying the classes we need is the process of assigning responsibilities to each class. This is simply saying for each class, it has methods, right? You need to decide what methods should be in that class. The verbs, the responsibilities. That means you ask yourself, what does this object do? Or what can this object do? Or what can be done to this object? That's how you decide what methods it should have. For example, a student. What does a student do, right? A student registers for classes. What does a student do? A student pays balance. A student changes his or her name, etc. Right? So that's what that's how you decide on the behavior, the responsibilities. Okay. In early stages, it is not necessary to determine every method of every class. Begin with primary responsibilities and evolve your design. Okay. We generally use verbs for name of methods. So methods usually are verbs. Okay. Any questions? We are done with those two components. Any questions about it, everybody? What do you think? Do you feel static variables? You remember in chapter 3, we discussed a static classes. Okay, a static method is one that can be invoked through its class name. And you remember this, right? Math.square-root. So remember we said, how do you invoke a method? You have to create an object and use that object as a handle to call the methods in that class, right? That's what we have been doing. But also we discussed that for static methods, you can simply use the class name dot followed by the method name. So this is one such example, math.square-root. This is the class name. It's not an object. You do not need to create an object for static method to be used. Okay, variables. So a method can be static. Variables can be static as well. And that's what we will look into. Determining if a method or variable should be static is an important design decision. Okay. So we declare static method and variables using the static modifier. Okay, it associates the method or variable with a class rather than with an object of that class. So this is very important. It's a simple statement, but it has loaded meaning. What this is saying is the method or the static method or the static variable, they belong to the class. They do not belong to an individual instance. Remember, an instance is an object, right? You have one class, you can have many objects. So a static method or variable belongs to that class and not an individual object, which means all the objects can share that static method and static variable. Okay, static methods are sometimes called class methods and variables, class variables. Okay, let's look at this. So this is how, okay, normally each object has its own data space. But if a variable is declared as static, only one copy of the variable exists. It's like this, you know, if you have a student, okay, a student class, and you have two objects now. One object A, object B. For A, you have a name, right? For B, you also have a name. So they occupy two different spaces, name S, and this name is T, for example. So for these two objects, they have two different spaces. But if you have a static variable called balance, for example, balance due, which is totally inappropriate. But suppose you have a static variable. That static variable is shared by both of them. So it will occupy this one space. And if you have another student object here, and another student has also a name, and the name is A, this also shares this one static variable. That's what this means. Okay, so normally each object has its own data space like these for instance variables. But if a variable is declared static, only one copy of the variable exists. So only this one copy, and they all share this one copy. That's what that means. Okay.
So I have a
And
question.
this is how you declare it. So, yeah, go ahead.
So does it get overwritten or does it save space? Like, I don't understand what it's doing there.
When I say space, this means in memory. When you
Right.
actually execute.
So can you, is it getting overwritten or is it's saving memory?
This is in memory. Yes, it's saved in memory. So in your memory is a list of bytes, right? So this is a object A, this is object B, this is object C, but then all of them share this space, which is for the static variable. So they all can access it, and they all, whatever they do, it affects this memory space. Does that make sense?
It does, but my question is, like, can I recall name A, name T, name S, or is it getting overwritten each time?
Can you recall? I don't know what you mean by can you recall. They are their own objects. So this is, we will look at an example, Jesus, and hopefully that explains it. But for now, just know they share this one. If it's static, they all can access it. They all can change it. But if you, for example, this object changes the value of this variable, that value will remain for this, will apply to this object, to this object also. Does that make sense?
Yeah, that makes more sense.
Okay. So if one object changes the value of a static variable, then that value applies to all the other objects. That means for the other objects, if you change it again, you will base your change on the previous changes. It applies to all of them. Okay. And that's what this means. Okay, all objects instantiated from the class share a static variable. Changing the value of a static variable in one object changes it for all others. Okay, let's look at, so this is how you define a static method. Very simple, just add this keyword, right? You can interchange them. No, not this. This data type, return data type must be next to the method name. This you cannot change. These two can be changed. You can change them. Okay. And because it's static, now you can use the class name dot method name. Any questions? Okay. And this is discussing what I just said. You can interchange them. Okay. By convention, visibility modifiers, let me put this up so that I can see. Okay, method is, recall that main method, okay, by convention, visibility modifiers come first. Recall that the main method is static. It is invoked by the Java interpreter. Your main is a static method, right? So the Java interpreter will invoke it without creating an object. That's why it is static. Okay, static methods cannot, this is very important, and again, it's loaded. Static methods cannot reference instance variables because instance variables don't exist until the object exists. Okay. However, a static method can reference static variables or local variables. And this is not very clear. So static method exists whenever the class is referenced. As soon as you reference the class, that static method and the static variable exist. But the instance variable do not exist until you create an object. That's why static methods cannot reference instance variables because they might not exist yet. Okay, that's why. So let's look at this class. This is a class, I created this class to just to illustrate. Okay, let's look at it. Private int length, right? This is added by PowerPoint, I think, the underline. Okay, now here is a static variable, right? And so we call them class variables because they are shared by all instances of this class. Okay, this is a true instance variable. And now let's look at this. Public static int double length. This is a static method. And when you do this, you're referencing length, and length is a private int instance variable. It will not compile. This is wrong. Because it's an instance variable, and this is a static method. A static method cannot reference instance variables. That's what this means. Okay, so do you understand that, everybody? This is an instance variable. So this is a static method. You cannot reference this variable because it's not there. It only exists when you create an object. But remember, why can we not do this? Because a static method exists and can be called as soon as the class name is referenced. So look at this. The class, oops, where are we here? The class name is referenced here. The class name is referenced. And so we can call this method because this method is static. So that's what we meant when we say as soon as a class name is referenced, the method exists and you can reference it, you can use it. So, but think about it. If you are, if in this here, if you are referencing an instance variable, then that variable does not exist yet because you don't have an object. So that will not work. That's why you cannot reference an instance variable in a static method. Any questions? You have to wrap your mind around this, right? A static method cannot reference an instance variable. This will work because this is a static variable. So this works. Okay. And this is okay because give me the string is a non-static method and you are referencing a static variable. That's fine because static variable exists as soon as the class name is referenced. And this can only be used by an instance, an object, so it already exists. So that's fine. Okay. And this is good. So this is okay, but this is the best way. And when I give you a test, you need to remember that. If it's a static variable, your method should also be static. Okay. If it's a static variable and you're using a non-static method, it beats the purpose of having a static variable. So this will work, but it's not good. So if it's a static variable, you have to use a static method like this. Static, a level is a static variable. Okay, any questions about this?
Is there any like repercussions, or is it just more like a convention?
It's actually not more like a convention even, because okay, well, think about it. What if you want to get the level before you create any class, right? Before you create any class, any objects, before you create, that's a great question, by the way, before you create any objects, then you cannot use this method because it's not static. Oh, I changed the color somehow. Okay, so if you don't create any objects, you cannot use this this method because it's not static. But this is static. You are supposed to be able to get it before you even create any methods. So that's the repercussion. That's a great question. Any other questions, everybody? It will be easy to remember this only if you understand this concept. If you understand this concept, it will be very easy to wrap your mind around this. That is, the static method and static variables are they are born as soon as the class name is referenced. That means they are ready for use. They are ready to be used as soon as the class name is referenced. Instance variables do not exist until an instance is instantiated. That means before an object is created. That's why, okay? Any questions, everybody?
Can you repeat that last part you said about instance variables?
Okay, for instance variables, they do not exist before an object is created. That's why a static method, a static method is born here. It already exists, right? As soon as you mention the class name. But the instance variable are not there yet before you create an object. How can the static method reference something that doesn't exist? That's the whole rationale. Does that make sense, Jesus?
Yes, that makes sense. Thank you.
Any other questions, everybody? Okay, let's go to the next part. Static class members, I have detailed explanation there, but I'm going to, okay, you look at it. And so let's look at this. I have loaded into my Eclipse. So I will, now, okay, you go to modules. All the source code is here. I don't know if you, we finished chapter 4, right? Okay, if you go down here, source code is here. Okay, they are all here. So you can download it and just unzip, and then you can import it into your Eclipse. To import, you just go to import. And this is, you open general and go to existing projects into workspace. That's how I grade your projects. So that's why if you don't have the correct project format, it will not import. Okay, so if the project is not zipped, you select this. If it is zipped, you select this, right? So you just select it and browse and find the project folder. I don't have one right now. I don't think I have one. But that's how you see. No, not that. I don't have Java projects. Okay, zipped, right? That's the project. That's what you sent me. That's why I keep asking you zip it and then open. And then I can import down here. I don't see it, but down here, finish. And then it's imported here. So that's how you import. Okay, now let's look at the slogan. Okay, another thing I want to share with you is you can change the package name. Sometimes you're so lazy that you forgot, not lazy, but you forgot. Let's just say you forgot to change the to create a package, and it will be a default package. It's strongly advised against. So what you can do is right click and go to refactor. Okay. Why cannot? You should be able to. You should be able to change the name. Somehow it doesn't let me. Okay, I will look into that and why it doesn't let me change the name. Okay, you should be able to. That's what I did all the time. But okay, let's look at slogan. Okay, this is the class from the book, and that's what is in the lecture notes. Okay, notice that here, this is instance variable, and this is a static instance, a static variable. For static variables, usually you will initialize it. Why? Why do we usually initialize a static variable?
Because you said it exists as soon as you
Reference.
like, reference it.
Yes, exactly. Because as soon as you reference the class name, it exists. And so you haven't done anything to it in your methods yet, because you cannot call the methods without an object if it's not static. So you want to initialize it. Okay. And so here in this constructor, you are incrementing count, right? This means as soon as you create an object, this count is incremented. And so this is get count. Notice that it's static because this is static. Okay, so okay, and this is the slogan counter, right? So let's see how many. We created one, we created another. That's 5 of them. And then when we say get count, let's run. And you have 5, right? You created 5 objects, and then this get count is 5. That's because this belongs to the whole class. So each object will increment. Its incrementation is based on the previous value. So it's called persistent. This value is persistent throughout the program execution. Okay, let's do a comparison. I have a note for myself so that I can remember what to do. Let's make private non-static. Okay, let's just call it count again. Okay, and I will do exactly the same thing so that you can see. Okay, and I'm going to increment it. So I'm doing exactly the same thing, right? And then I cannot return it twice, right? So at a get count method, I see I have the notes to myself so that I will be able to remember. Okay, so here I will just do public static. I will do this so that you can see get count again. Okay, and return count again. Public static int get count again. So you see that it cannot make a static. It tells you, right? Okay, let me do this. So you can see it says cannot make a static reference to the non-static field count again. I also have a syntax error. This is from Python. In Python, you don't have that. In Java, you do. So I sometimes, okay. But anyway, so now you see the why, right? That's why we say you cannot make, a static method cannot reference a non-static method. Everybody, you understand that? Okay. Oh, not that one. So let's take this off, okay? Now it's okay, right? Okay, so let's go to our class. This is the driver, right? Okay. And the slogans created for this one. We cannot do slogan get count again. We cannot do that. We cannot do it because get count again is not a static method, right? It's a non-static method. So you have to create an object. So let's use object. Oh, this will not be okay because we are doing, we can do this. Instead of doing it here, let's do it here. Okay. Let's simply do it here. Right? We can do this. And put it here. Okay, so let's run this. Okay, so you can see the first one is the same, 1, 1, but the second one, slogans created becomes 2. That's the static method. That is the static variable. Now you have 2 objects, and that count got incremented from the previous 1. Now it's 2. Now it's 3. Now it's 4. Now it's 5. Versus the instance variable is always 1. Does that make sense, everybody?
So
Does this explain to you? Does this explain answer your question?
Yeah, kind of.
Okay.
Kind of.
I think that really helped. It just like shows that like with the 2 statics, it shows that what you put in will like stay. What you put in for the input for the static will go in and then you know, stay in there and save, and then it'll keep going and going and going. So it shows that the count is actually working compared to the non-static is just, you know, resetting over and over and over and
Yes.
over, right?
Yes,
So it's like when you create like a loop, basically, like if you were to do a loop correctly, when you want to do like the increment, like keep it going.
No, don't think about this as a loop, Danny. It's think about it as a space where you have a variable named count, right? And all the 5 objects, when you create an object, think about it. When you create an object, you're incrementing count, and you only have that 1 memory space. So when you increment it, that value keeps incrementing. Versus a count again, it's 5 different variables.
Gotcha.
So every time you create an object, you're incrementing just that 1 variable for that 1 object. And then the second time you are doing it for another object, the second time for another object.
Okay.
Versus this count is just 1 place, and you're doing it to that 1 place.
And so it doesn't matter who calls into that space. Once it gets called into that space, the value changes. Gotcha.
Yes, because it belongs to everybody. It's shared by all the objects.
Yeah, that makes more sense now.
Yes.
Yeah. Okay. Yeah, you just imagine that 1 place, right? Everybody. It's just like the lobby. It's shared by all the rooms, and everybody goes to that. You make a difference. So.
I have another question. So count again. You're saying you created 5 objects.
Mm-hmm. Yeah.
Those are 5 different addresses?
Yes, 5 different addresses. They are 5 little houses. Yes. And you may think, oh, this is just 1 object. No, it's 1 reference variable. But every time you are reassigning, you are letting it pointing to another object. Does that make sense? Okay, let me show you what that means.
Can that lead to issues?
I'm sorry?
Can that lead to issues with either like
the issues would be What issues do you think there will be?
I was thinking either with this, they're all sharing the same space, either like too much data is being, no, but also like if they're all sharing the same space, wouldn't it be, like, confusing with like count or slogan is getting 1, 2, 3, 4, 5, but then there's another going in that is maybe going with another count. Since they're all sharing the same
No,
space,
okay,
would they
let me
be
explain this to you.
okay?
Is it because
Okay, let me
that wouldn't be a problem because it's not
okay.
saving that data, it's changing it each time. So it wouldn't really, it's only one, like the value would only be like one each time, for example.
I don't know. Are you talking about amongst yourself or me? I don't know. But okay, let me show you. Remember the element. So the first time object is, remember object obj is just a reference variable. So its address is pointing to this, and this is remember. Okay, I will just put that there so that you know which one it is. And then we are doing this, right? When we do this, we are creating a new object here. What is? It's don't, right? Okay, so don't. We create this new object, and this is not pointing there anymore. It's pointing to this. And then we created another one, whatever that is, and it's not pointing to that one anymore. It's pointing to this. And then we created another one. It's not pointing to that anymore. It's pointing to this. And then this. Okay, that's what happens here. So the first time is pointing to remember the element, that object. The second time is pointing to this, and then this, and then this, and then this. So eventually, what is object? What does it reference? It references this one object here. All the others are lost. Remember the Steve Wozniak example, Steve Jobs, Steve Wozniak in chapter 3, right? We said Steve Wozniak was lost. He is garbage. I'm sorry, I don't want to say that. That object is garbage collected, right? I respect it to him so much that that's bad. So that object was garbage collected. And here also, after this assignment here, okay, after this assignment, all these 4 objects are not in existence anymore. They are floating around, and then the garbage collector will collect them. So eventually, this is just pointing to one object. That's one of your questions, I think. Another question is, okay, so now for each object at that time, you have a space called count. Count again, count again, count again, count again, count again. Okay, so each one belongs to that one object. Versus here, you have one shared space. Okay, where are you? Okay, in this whole address space for the class, for your program. You know, when you run the program, the CPU will assign you memory space, right? In this address space, you have a space called count, and that's shared by all of them. They all can reference it, they all can use it, they all can do things to it. And that's the count. And this is the count again, count again, count again. So that's that. Does that make sense, everybody? No?
Yes, it does.
Yeah,
it does.
Yeah, it does.
I have one
Okay.
one last question.
Okay.
When you're saying object equals new slogan, it's not creating like a object one. So like you're saying it's lost, right? Like it's garbage collected. Can you go back
This
and
one. No, you can never go back and get this one, because once you do this, okay, I know this is messy, but see that I cross this out. That means there is no handle pointing to this anymore. This is originally, now it's gone. This object, there is no handle. Originally, the very first time, how do you reference it? You reference it by obj. Now, after obj, it's pointing to this object. This pointer is lost. So no one is referencing it. No one knows its name. He is just not existent. You
Yeah, so it's-
cannot, he or she, you cannot reference it anymore.
So it's not like our last project where we made like 5 objects and each one had a name, or if we use an array and have an array, and we can call each object back.
Yeah. If you do this, okay, can I do this? I think I can, right? Okay, let's do this. Oops. Okay, and I will just take that away. So you can do this. It's still the same. It will still be the same. Now they are still in existence, right? Because they are different objects, but it's the same concept for the instance variable and the static variable. And then we have to change all this, right? 1, and this is 2, this is 3, this is 4, 5, oops, and this is 5. Okay, so this is 4, this is 3. Am I still recording?
Yes.
Okay, good, thank you. Okay, so you look at this, this is still the same, right? Okay, it's still the same. So now can you go back and reference object 1? Yes, because you remembered it. It's still here, you see? Now you can still do object 1. You can still reference it. Okay, just now, before this, when you reference OBJ, it will be the last one. So this is still existing. That's because we never obliterate them. We have 5 different addresses. We have 5 different reference variables, OBJ1, OBJ2, OBJ3, 4, and 5. And so it's referencing. Okay, so they are existing, but they all share this one memory space, which is the count variable. Does that make sense, everybody?
Yes, that makes sense.
Okay, good. Okay, that is that. Okay, so okay. Now, I think we are done with it. Let's see. Why can't a static method reference an instance variable? Oh, I have the answer there already. But you think, let's not look at that yet. You think, why can't a static method reference an instance variable? Everybody?
Because it's not created yet.
Yes, that's correct. Yes. Because the instance variable is not in existence. It might not be in existence yet. So to be safe, you just simply cannot reference it, right? Because a static method is used with the class name, dot method name, while an instance variable can only come into existence after an object is created. Okay. So now we have 20 minutes. Let's go to class relationships, okay? If you are all good with what we discussed so far, how do you feel? Are you okay? Okay, class relationships. I remember what I said. If you, to design, right? The software development activities, what are they? Understand the customer's requirements, analyze it, and then design, right? Create your design, which means create your solution. and then you implement that code, that solution using a programming language, and then you test it and maintain it. Okay, that's the software development activities cycle. Now we discussed that, and we talked about static variable. Let's look, and I said your design is really identify the classes and objects and their responsibilities and establish their relationships. So that's what that is. You need to identify the classes and objects, identify their responsibilities, and then you need to establish the relationships among the classes. So let's look at that. Okay, there are three relationships: dependency, A uses B; aggregation, A has a B; and inheritance, A is a B. And we are not talking about inheritance in this class. We are only talking about those two. So let's look at that. Dependency means one class depends on another. So if you look at this slogan counter, which class is it dependent on, do you think? That means for this class to
the counter,
work,
the driver.
you must have, okay, let me repeat that. For this class to work, you must have which class?
The slogan class.
Yes, the slogan class. That means slogan counter depends on slogan. If slogan does not exist, you cannot have this slogan counter class. That's called dependency. And that's also called uses. That means slogan counter uses slogan. Okay. Slogan, does it depend? What class does it depend on?
Are you talking about, like, I mean, I guess the strings?
String. Yes, string, remember, it looks like a data type. It is a class. Remember, you have many methods for the string class. So it is just used so often, we sometimes forget it is actually a class. So this is a class, okay? And slogan depends on this, but we usually don't draw it out because it's not necessary. Okay, so that's the uses relationship, okay? Sometimes some classes depend on themselves. For example, the string class depends on itself. If you look at this, this is a string object, and this is a string object, right? String str3, str1, they are string objects. And when you call this method, it depends on the string. So this method is in the string class, and this method needs another string object. That means it depends on itself. We call that self-dependency, okay? And now let's look at another class. This class I'm going to, this is the class we are going to look at. I have the explanation, but I have it here. So let me load it. Okay, rational number. So look at this, rational number and rational tester. So what does this class depend on?
That would rely on rational number.
Yes, it relies on rational number. Without rational number, this class will not work, right? So rational tester uses rational number, okay? And let's look at rational number. Rational number, okay? We will not go through the actual code. You know, once you understand, gradually you will find this coding is easy. it's easy once you have the logic done. Okay, so I'm not going to do that. But here, look at this method. This method depends on what? on itself, on the class itself, because without rational number, this method will not work. Why? Because you are returning a rational number, and that's the class name. So this is called self-dependency, right? And you are creating a new rational number. Okay, so that's self-dependency. You are depending on it. This one also, you are depending on rational number because it's the parameter type and returning type. Okay, and this one also. So this is easier to look at than the slides, I think. And this is also, and this is also, right? True for this also. And so these methods all depend on itself, the class itself. And now let's look at this. Remember what I said. I said all your methods for now in chapter 4, I said all your methods for now should be private, should be public, all your methods. But later on, you will be able to design your private method. And here is a private method. Why do we make it private? It's because when you know this method will not be used outside of this class, it will only be used inside the class as a helper, as a supporting mechanism, as something to simplify the code, then you make it private. Once again, it's not used outside the class. It's only used as a supporting piece of a segment, a supporting segment, task, smaller logical task for the bigger logical task. Okay, so reduce. Where is it used? Let's see, reduce is used here, right? Because this method is inside this class, you do not need an object to call it. You can just reference it by name because it's within, you can see it. And so it's private, right? That's that. And also inside the reduce, you're using the GCD, which is here. Okay, this is a private method also. This private method is used by another private method. So once again, why do we have private methods? When it's not necessary for the client, for the program that for the class that uses this class to see it. They don't need to know about it. They don't use it. And you have this method so that you are simplifying your code. Otherwise, think about it. You have to put all that code here, right? And making this constructor crowded and not as organized. So this is an organizing mechanism. And you can use this method anywhere if needed. You don't have to copy and paste the code again and again, right? So that's private method. Any questions about that? No? Okay, you all understand that? Okay, that's that. Okay, so aggregation. Okay, aggregate is an object that is made up of other objects. Therefore, aggregation has a relationship. Has a, uses a is a dependency relationship. Okay, a car has a chassis. That means chassis is part of the car. A car is composed of chassis. They are all dependency, but we are distinguishing them because the purpose is a little bit different. Okay, an aggregate object contains references to other objects as instance data. As instance data. Remember, what are instance data? The private variables, the attributes, right? So if you think about student, employee or student and address. Address, you have decided it should be a class. So this is a class. Student has an address as its attribute, as one of its attributes. So we say a student is composed of address. So student has address. So the relationship between student and address is aggregation. Any questions? Okay, another example. book, and author. Can you represent author as a single string, everybody? Author.
Yeah.
Okay, I think I will leave that there. I will leave that there. Okay, let's have another example. Computer, CPU. What's the relationship?
So, a computer has a CPU
Yes. Why?
because the object would be the CPU and the class
Computer.
would be the computer.
Yeah, both are classes because a
Oh, okay.
CPU you cannot represent CPU with a single string or anything. You're right, it's an object, and computer is an object. But CPU is part of a computer. A computer is composed of CPU, so this is an aggregation relationship. Okay, that's what that is. It's basically one class has another class as part of its instance data.
And it's that one class not really relies, but it won't be able to function properly without that. But however, CPU can like function without computer, but computer can't function without CPU.
Yes, that's very good. That's
Okay.
absolutely correct. CPU can function without computer. A computer cannot be used without a CPU. Computer is useless without a CPU because a CPU is part. No, a CPU is part of a computer. Yes, you are absolutely right. Okay, so let's look at this. This is the student. I'm going to open this also, and I think this is faster. To show you, okay. So this is the student body, okay. This is the student body class. This is the driver, right? The main method, which is static. We just discussed static, and it created several addresses. If you look at it, so how many parameters does the address constructor accept? If you look at this,
4.
4. 1 string, 2 string, 3 string, and this obviously is not a string, or it's an int or long, right? Okay, 4. Yes, that's correct. Okay, we are creating 3 addresses and 1 student. And student accepts 4 parameters: string, string, address, address. So now you see student has address as part of its instance data. This is the constructor. It accepts, it requires 4 parameters, right? Okay, 2 strings and 2 addresses. And so these addresses are created, these objects are created really because our student object needs them. Okay, so then print out the student, print out the student. It's a very simple program just to show you the relationship. Let's look at address. So this is the address class. And we have string for these 3, and we have long for zip code. So when you create an address, you need to give me 3 strings and 1 long, right? And you initialize them. And then this is the 2 string. We, for simplicity's sake, we don't have the accessors and mutators, which you should always have, because what if I entered the wrong street address? I need to change it. So you need to have the set street address method and get street address method. Okay, all those mutators and accessors should be here. But this is just for simplicity's sake. Let's look at student. So you can see this is part of student, right? So student, we say this, student is an aggregation of address. Okay, student is an aggregation of address. You have 2 address reference variables here, right? Okay, so student needs 2 fields to be address and 2 fields to be string, okay? And this is the constructor. And this is the two-string method. Once again, just because we are illustrating the relationships among the classes, we are not really manipulating the classes. Okay, so that's that. Do you have any questions, everybody? Looking at this. So let me ask you, who is using whom? Who is using whom among these three classes? Give me the relationship. Tell me the relationship. Okay, when it's an aggregation, so student is not just uses, student has an address. This is an aggregation relationship. The importance is that if in your design you specify student is an aggregate of address, you know that address is part of the student instance data. So you know that address is the instance data. You are not just using it randomly. It's part of you. It should be a private instance variable. That's the importance of it. Okay, because think about student body is using student. This is the simple usage relationship, right? It's not part of student body. Student body is just using it. Can you just take all this away and student body is still there, even though it doesn't do anything? Yes, but for student, if you take address away, it's not a complete student anymore. That's why it's important to distinguish between uses and aggregate. Okay. Any questions? I think we finished this, right? Oh, here, this is something we need to discuss. This is how you look at it, okay? This way. I'm recording, right? Okay, this is the usage relationship. That is uses, okay? And this is the aggregation. This points to the class that has this class as its instance fields. So this is here, not here, not here. So this means student is an aggregate of address. Okay, very important to remember. That's the UML. You remember we discussed UML, right? Okay. So I explained it here. You can look at that. We are running out of time, so I will stop here. This reference, we already discussed this already, I think. Did we? Yes?
Yeah, I believe so.
Yeah, so you can look at this. I gave you detailed explanations here, so look at that. And next time, we will go to interfaces and method design, everybody. Okay, I'm going to stop recording.